Hello, hello. Happy Friday, folks. Today is day 5 of 6 of Unit 11. Right, we are rapidly closing in on the end here, and let's finish strong, So you've got two warm-up problems here. Find the volume of a cone and find the volume of a prism, so two of our 3D figures. Take a moment to pause the video and try out these two warm-up problems. All right, and we're back with some answers. So take a moment and check your work. Remember that the volume for a cone can be given by area of the base times height divided by 3. And after we sub in our values, we will end up at 500 pi cubic inches. Right? And then the volume of a square prism, area of the base times the height or the lateral edge. And at the end of that, we get 576 centimeters cubed. All right, let's push forward here. So take a moment and just write down how you understand this, right? How would you describe the relationship between cylinders and cones? Take a moment, pause the video. How would you answer this question? All right, hopefully you're saying something along the lines of the volume of a cone is equal to 1/3 of the volume of a cylinder, assuming that we have the same radius and the same height, right? The bases are congruent. So kind of raises the question, what would we do if we want to find the volume of a pyramid, right? Well, let's consider that we said that a cylinder was sort of the same thing as a circular pyramid. I'm sorry, a circular prism. Right, two congruent bases, both of them being circles. So cylinder is like a prism, and if we think that way, then we could probably say that a cone is like a circular pyramid. Right, well, if that's the case, all we're doing is calling it a different name, but that relationship still holds true, that the volume of the circular pyramid is 1/3 the volume of the circular prism, right? And really then, we should be able to just make some swaps on what shape base we have, right? There's no reason that it needs to be a circular pyramid. We could have a triangular pyramid, we could have a pentagonal pyramid, right? Really any pyramid at all. So the volume of a pyramid is equal to 1/3 the volume of the prism with the congruent base and same height. Right, the reason that's useful is because if we want to find the volume of this pyramid, then we can find the volume of the prism that has this square base and this height. And then we can just multiply by 1/3 or divide by 3. Right, so in this particular case, I'm going to draw a prism around this pyramid, just so we have a visual of what we're talking about. You also could probably visualize it quite easily or just make some substitutions into the formula that you would know how to do. But for the sake of what we're doing, I will draw out a prism. All right, so hopefully now you can see this prism as being drawn around our pyramid. So if we want to find the volume of that prism, it'd be the area of the base, which is 81, 9 times 9, multiplied by 8. So 81 times 8 would be 648, quick maths. And then that just needs to get divided by 3 because we want 1/3 the volume of that prism. Right, so I'll hop into my calculator here. And that looks like 216 cubic centimeters. Right, really that's what gives us our formula for the volume of a pyramid. So the volume of a right pyramid, again, right here meaning that the height is perpendicular to the base, can be given by the formula that volume is equal to the area of, the volume of the prism divided by 3, but remember that the volume of the prism is area of the base times the height, and then we divide by 3. right? So you might notice same formula as yesterday, right? Again, that's because a cone is just a specialized type of pyramid, but that formula is going to hold true for our other types of pyramids as well. All right, so you've got two practice problems down here. They're gonna look like they're a wild step up from what we just did. I think they are a step up. I don't think it's quite so wild, right? Basically, the reason I'm giving you these problems is I want you to just pull back. How do we solve for these these regular polygons and their area like we did in Unit 10, right? We've done this in Unit 10. You know how to do it. You just need to pull it out of the filing cabinet, right? And some of the things that I do want to point out, slant height is still here in our hexagonal pyramid, but slant height is this edge down the middle of the face, right? It's sort of like an apothem for a lateral face. It is not this edge or this edge or that edge. Those are the lateral edges, right? Those are the edges of those lateral faces. So slant height, this segment right here, and then your hint as to how to approach this problem, because I'm only giving you two values, but I trust you to figure out the rest of them. There are multiple right angles to be found in this pyramid, and that sets up multiple right triangles that you can use. So for example, you could take this height, this apothem, and this slant height, and that would be a right triangle because the height is perpendicular to the entire base. So it has to be perpendicular to this apothem. Right? Likewise, you can also use the right triangles of the radius d apothem and half of this base edge, based on what we did in Unit 10 when we had two radii and a base edge. All right, so just some hints for you to approach number one. And then just one last reminder that when you have a hexagon, there's no reason to do trig. You should be able to get an exact answer. Once we get to a pentagon, then you will probably need a trig function. So these two problems are left for you, and we will do that in groups and enter it into the Go formative, and I will see you on Zoom.